Hey everyone, my name is Mithun, and today, along with my team, we're going to be talking about a project which is fake news detection. Now, throughout the course of this presentation, we're going to go over a bit of details about what this project really is, why do we need it, how we did it, and finally, we want to show you what we have so far. And I really want to emphasize that this is just a starting point. We are planning to work on this for quite some time now, and we'll actually plan to work on it in the future as well because we want to make this as perfect as it can be. So, without further ado, I'm just going to go into a bit of details about what this project really is. Now, me along with my team, we're taking a class in natural language processing, and this is very important in AI, as we all know. Now, AI has been around for like a really long time. It's been represented in a lot of movies, and we've all seen what it's capable of. And with the emergence of ChatGPT, it piqued everybody's interest, and with good reason too, because if it's able to do all these amazing things, why can't we use it to detect fake news? That's what we're trying to do, and that's really what this project is about. Now, why do we need it? Now, one of the main reasons that inspired us to do this project is Metasphere. Now, that project essentially does the same thing, that is to detect fake news, but on a much larger scale because they have nearly unlimited resources. So what we're trying to do over here is essentially try to lower the scale so that we can accomplish something that on a much finer scale, because we don't have to actually think about the larger problems, so that once we perfect this, it serves as a framework for anybody else working on this project as well. And the reason why I keep going back to Sphere is because what they're trying to do, it's pretty amazing, because right now they're actually trying to filter out the pages in Wikipedia because they upload around 17,000 pages on a regular basis, and filtering out all those content takes quite a bit of time, and it's frankly quite amazing. So essentially, why do we need it? Now, fake news has been around for a really long time, and as much as we'd like to, it's something that's never going to decline. It's only going to keep increasing because anybody with a phone can so much just post anything about anything, and there are a lot of people who actually believe it as well. So that's why we're actually trying to work on this so that it lowers that and just have actual news that everybody can view and believe. So how do we do it now? Over the course of the presentation, we're actually going to be talking about the data set, the model that's actually the heart of this actual project, and essentially just give you a bit of output to show how this really works. So now I'm going to be talking about the tools that we use for this. And essentially, we're just going to go over what we actually needed to actually make this project happen. Now, the programming language that we went with is Python. There's no specific reason why we just chose this specific language. It's just that throughout the course of this course, we actually just use this for multiple assignments, and we're just really comfortable with it. But what I'm trying to emphasize is that we can do it with pretty much any programming language as well. Now, the IDE that we used is Jupyter Notebooks. Now, executing this code takes quite a bit of time because it's actually quite resource intensive as well. So each time we actually had to debug this whole thing, we'd have to actually wait for a few minutes to make it happen. But the benefit of using Jupyter Notebooks is it allows to execute just a specific part of the code so that once we eliminate that problem, we can actually just move on to the next. And that's really why we just went with Jupyter Notebooks as well. And now Jasjeet is going to be talking more about the model, and we're going to go on from there. Over to you, Jasjeet.
Thank you, Mithun. So, as Mithun said, I will be talking more about the data set and how it works. So, we went on to work with this data set called the Fake News Net, and it's open sourced and is provided on GitHub. We actually use just the sample files for uh, training our model. And this data set is a comprehensive data set that includes news articles labeled real or fake. And it spans various resources and has a lot of diverse articles and data to train on. I would like to explain to you more about how we use this. So there's two sections called the Gossip Cop and the PolityFacts. It's further divided into fake and real for both of those sections, and we only focused on the fake and real sections of the PolityFacts, since we're only going to be predicting the political headlines and going to be working with that. This dataset is in JSON format, which was very easy to work with. And it had texts, images, and publishing date. Along with that, we made sure that there was titles, URLs, and unique identifiers. And if any of those information was missing, we did not take that data into training our model, and that data was deleted off from the training set. Um, some more things I would like to add to this is that we are only very narrowly focusing on the PolitiFacts to have a better predictability, and to better train our models, so we can see what the results would be, rather than having a lot of training data and then finding out that our data set isn't good enough. And we actually trust this data set since it's been used by various other projects that have come out, and their predictability looked really good to us, so we went on with this data set. This data set serves as our compass, guiding us through the dynamic landscape of news authenticity. And I would further like to uh, hand over the mic to Vrenda, who would explain how the model works.
Hello, everyone. I'll be talking about the model that we used throughout this project. Now, NLP enables machine to comprehend, interpret, and generate text that is similar to that of humans. In this project, we use sequential model, which is a type of neural network designed to process data sequences. For our project, making it ideal for tasks like language modeling and text classification. So the question is, what is a sequential model? A sequential model is a type of neural network architecture in which information flows sequentially from one layer to the next. The architecture is especially well suited for tasks where information order is important, such as language processing. So how did we use sequential model? We used a sequential model to analyze the textual content of the news article in our fake news detection project. The model sequentially processes the text, capturing nuanced patterns and relationships between words and sentences that could indicate the presence of any misinformation. Moving on, data reprocessing. So in this project, we perform extensive data pre-processing before feeding the data into our sequential model. Text cleaning, which is the process of removing irrelevant or unnecessary elements from the raw text data. Tokenization, that is breaking down a text into smaller units, usually words or subwords. And vectorization, which is converting text data into numerical vectors, which were used to convert the textual data into a format that the model could understand and learn from. Moving on to the model architecture. Our sequential model was built with several layers, including embedding layers for word representation, recurrent layers for capturing sequential dependencies, and dense layers for classification. This architecture enabled the model to learn and generalize the data patterns. Talking about training the model, we use supervised learning with a labeled dataset to teach our model to distinguish between real and fake news. The model's parameters were adjusted during the training process to minimize the difference between its predictions and the actual labels, gradually improving its ability to classify news articles. Now over to Devang.
Hey everyone, so I'm going to talk to you guys about how we trained our model. For that, I have two major components. We have epochs and early stopping. So I'm going to explain epochs first. To understand epochs, we are going to have to go over what a batch is and what iterations are. So within an epoch, there are multiple iterations, and each iteration is just the different batches that the training dataset has been divided into being trained or being used as a training data for the model. So for every batch, in every iteration, the model tries to predict the correct answers. And if it's not able to do that, it will go back and it will try to guess again. And it will keep on doing this until it's done with all the batches in the training data. Once it's done with that, then it checks the model against the validation set, which is an unseen set of data. once this is done, that's one epoch. As you can see, we had 15 epochs right here. And you can also see that once we reach epoch 11, for some reason, we stopped. Now this is part of early stopping. Now in early stopping, what happens is we stop training a model once the validation set accuracy does not improve for a particular period of time. In our particular case, what we have done is we have set the patience parameter as 3. What this means is if the validation set accuracy of the model does not increase for 3 epochs, it's gonna stop. As you can see right here, it stops at epoch 11, it says early stopping, and it goes back to the model at epoch 8, because that is the model where we had the highest accuracy. And then we use that model as the main trained model for our particular project, and we achieved an accuracy of about 83%. Next up, Amisha is going to talk to you guys about the outcomes and the future direction of our project.
So let's talk about the output now. When we run the program, this is the first set of output we get. As Devang explained earlier, epoch here controls how many times the model iterates over the entire training dataset during the training phase, allowing the model to learn from the data by adjusting its parameters. As per the code, the model is set to train for 15 complete passes through the training dataset. However, the stopping at 11th iteration is because early stoppings help prevent overfitting, as it avoids training for unnecessary iterations, and it helps in capturing a model's generalization capabilities. So this is the next and the final part of output. Predicted probabilities here displays the predicted probabilities for each class, fake and true, for the given data. So what is a predicted class? So the predicted probabilities are converted into class labels by comparing the probability scores. For instance, if the probability of true index 0 is higher than fake index 1, for a specific prediction, it assigns the class label 0, interpreted as true. Otherwise, it assigns 1, which is interpreted as fake. What comes next? So this is the very beginning of our project, and we're preparing for more features that will be added to this project. Let's talk about the advancement first. Enhanced algorithms. For enhanced algorithms, we'll further focus on refining the model, incorporating advanced NLP techniques, and we'll leverage newer datasets for better accuracy. User accessibilities. In order to make the tool accessible to a wider audience, you can look forward to a user-friendly interface and many other API integrations. Then come future goals. We have feedback loops and scaling. Feedback loops. We're planning to implement mechanisms to gather user feedback for continuous improvement of the detector, allowing it to adapt to evolving misinformation tactics. Scaling. So, as I mentioned earlier, we are planning to make this tool accessible to a larger audience, and thus integrating it into various social media platforms is something which we are focusing on in the upcoming releases. Overcoming challenges. We have data privacy and model bias. There could be worries regarding the security and handling of personal information that user provides or that the tool collects during its operation. Models can unintentionally learn biases present in the training data, leading to unfair or inaccurate classification. Additionally, lack of diversity in the training data may result in skewed perspectives, impacting the model's ability to accurately detect fake news across the different demographics or viewpoints. In order to overcome it, we'll be utilizing diverse datasets representing various demographics, ideologies, and cultural perspectives to mitigate biases arising from underrepresentation. Alright, so these are our references for this project. Thank you.